Hello students, today I will discuss refraction of light through a prism. First you pause the video for a while and write the question. See question number 84. Pause the video for a while and write the question. A ray of light is incident on one face of a glass prism and emerges out from the other face. Trace the path of the ray and derive an expression for the refractive index of the glass prism. 2011. Okay. Let us draw the front side of a triangular prism, which is also known as principal section. ABC is the front side or principal section of a prism. Let us consider ray of light incident on the surface AB. Let us consider a ray of light incident on the surface AB. In absence of prism, the ray would have gone straight. In absence of prism, अगर प्रिज्म नहीं होता तो रे सीधा जाता ऐसे. In absence of prism, the ray would have gone straight. Here PQ is called the incident ray. Let us draw a normal at point of incidence Q. Then this angle, incident ray and normal, the angle between incident ray and normal, this angle is called the angle of incidence, say I1. And the ray is traveling from air to glass, that is from rare air to denser medium. Refraction occurs, so light will travel towards normal. It will not go straight, but it will bend. And in which direction? It will bend towards normal, so it will go like this. This is the refracted ray. And the angle between the normal and the refracted ray, let us call this as R1. So for the surface AB, I1 is the angle of incidence, R1 is the angle of refraction. Let us draw a normal at the point of incidence R. Okay, then the angle, this angle, we call it as R2. Now light is traveling from glass to air, so from rarer to denser, so it will move away from the normal. It will not go straight, not go straight, but it will move away from the normal. So it will go like this, it will move away from the normal. Okay, then the angle made by this normal and this ray, refracted ray, we call this as I2. So for the surface AC, I2 is the angle of incidence and R2 is the angle of refraction, or you can say R2 is the angle of incidence, I2 is the angle of refraction. But for a prism, overall we call I1 as the angle of incidence, I2 as the angle of emergence. Now if you produce this ray in the backward direction, okay, when you produce them in the backward direction, it meets somewhere here M, then this angle we call as the angle of deviation, denoted by del. Del is called the angle of deviation. This is the incident ray, this is the emergent ray. So the angle between the incident ray and the emergent ray is called the angle of deviation. Now consider the triangle NQR. NQR. In this triangle, the angles are R1, R2 and N. These are the angles R1, R2 and N. The sum of these triangles is 180 degree. Okay, N plus R1 plus R2 equals to 180 degree from triangle NQR. Now you consider the quadrilateral AQNR. This quadrilateral, in this quadrilateral, this angle AQN is angle 90 degree, ARN this is also 90 degree, this angle is A and this angle is 9. So sum of the four angle is 360 degree. Okay, now the value of AQN is 90 degree. Similarly, the value of ARN, this ARN is also 90 degree. Now A plus N will be what? 360 minus 90 minus 90. which is equal to 180 degree. Now equate equation 1 and 2. Since the right hand side of both the equations are equal, so the left hand sides will be equal. So we can write n plus r1 plus r2 equals to a plus n. This must be equals to this. Now cancel n from both sides, so we have a equals to r1 plus r2. In triangle MQR, this del is the exterior angle. Let us draw the triangle MQR. Now in this triangle MQR, del is the exterior angle, and we know that exterior angle equals to sum of remote interior angles. So this angle must be equals to this angle plus this angle. So del equals to MQR plus MRQ. Now what is MQR? Here you see, if this is I1, then this is also I1, and this angle is R. This angle is R1. Okay, this angle is R1. If this is I1, then this is also I1. Why? Vertically opposite angle. So these two angles are equal, and this is R1. Now what is MQR? MQR we can write I1 minus R1. Got it? Complete is I1. From this cut this portion. So I1 minus R1 is MQR. So MQR is I1 minus R1. Now what is MRQ? Here this is I2. So this is also I2. This is called vertically opposite angle. Same logic. These two are equal. And this is R2. So I2 minus R2 will get MRQ. What is MRQ? This I2 minus R2. So MRQ is I2 minus R2. Now we'll take I1 plus I2 and we'll take minus common. So we have R1 plus R2. Now what is R1 plus R2? You see, this R1 plus R2 is A. So we'll substitute A here. Thus we have del equals to I1 plus I2 minus A. This is A. Here del depends on I1. That is, angle of deviation depends on angle of incidence. For different value of angle of incidence, the angle of deviation will be different. It means when this angle I1, angle of incidence changes, the angle of deviation del will also change. How it change? When if you go on increase I gradually, you will find the value of D first decreases, becomes minimum, and then again increases. Okay, as I increases, the value of del first decreases, becomes minimum, and then again increases. Okay, it is found that when del is minimum, then I1 becomes equals to I2. That is, angle of incidence becomes equals to angle of emergence. That is, at minimum deviation position, this I1 and this I2, they will be same. If I1 and I2 become same, now this R1 depends on I1. So when I1 is I2 equals to I1 equals to I2, then R1 will be equals to R2. Thus, at minimum deviation position, del equals to del M, I1 equals to I2. That implies R1 equals to R2. Let I1 equals to I2 equals to I, and R1 equals to R2 equals to R. Okay. In equation 4, we will substitute del M, I1 in place of I1 I, in place of I2 also I. So I plus I will be twice I. Now twice I will be A plus del M. Minus A comes to this side, becomes plus M. Now twice I is this. So what is I? A plus del M by 2. Now in equation 3, A equals to R1 plus R2, we will put the value. R1 is R, R2 is also R. So R plus R, 2R. 2R equals to A. So R equals to A by 2. Now refractive index mu equals to sin I by sin R. Here I is A plus del M by 2 and R is A by 2. This formula is known as prism formula. For thin prism, these angles will be very small. As we know, sin theta tends to theta when theta equals to 0. Therefore, mu will be this. Sine of a plus del m by 2 is a plus del m by 2. Sine of a by 2 equals to a by. Now you cancel 2, multiply mu into a. Then you find del m. Del m will be mu a minus a. Now you take a common. This formula is true for thin prism. Thank you very much.